Hello and welcome. Today's lesson is a continuation of growth and decay word problems. This will be part two of the lesson. On this particular problem, we have a situation here and we're asked to decide which of these graphs would describe the situation. So we'll start the same way as before. We always want to find your rate, the y-intercept, and the equation for this problem. When we look at this problem, the amount of freshwater fish in a pond, so here's a pond and there's some fish in it, is expected to decrease, so we see a keyword right there, by 8.5% every year unless new fish are added to the pond. If there are approximately 10,000 fish currently in the pond, which graph models the situation after X years have passed? So right there, we know that it's decreased, so it'd be a minus. And we also notice that we have a percentage, so we're going to change that to a decimal by writing 8.5 and then moving the decimal point 2 decimal places to the left and adding the zeros. So that means my rate is going to be 1 minus 0.085, and I'll get 0.915. So there we go. That's going to be my rate. And then my y-intercept, we notice that there's 10,000 fish currently. So that's our starting value, our initial value. So 10,000 will be our y-intercept. So that means our equation will be 10,000 and the rate is 0.915 to the x power. Now, by looking at this, we see that our initial value is at 10,000. And if you notice right here on graph A, we have initial value of 10,000. Also on graph B. On graph C, we have like around 14,000, between 14,000 to 16,000, so these 15,000, so that is wrong. Here we also have at 10,000. In fact, we notice that A and D are the same graph, so that was a typo. So let's go ahead and cancel letter D because it's the same as letter A. And we're going to decide between these two graphs. The reason why I say I'm going to choose between these two graphs because we eliminated this one and this was a typo, so we're left with these two. So both of them start at 10,000, and we need to decide which one of these is going to be the graph represented by this. So what we're going to do is we're going to look or evaluate this equation for the value 1. So we're going to use a calculator. So here's a calculator. So let's go ahead and enter our value, which is 10,000, open parentheses, 0.915, close parentheses, raised to the first power. Okay, and we notice that the amount is 9,150. So let's write this down here first. So we notice that when it's 1, we're going to have 9,150. So let's look at 1 here. And if you notice right here, this is less than 2,000 and is between 1,000 and 2,000. Okay, over here at 1, we have about 9,000 something, which is very similar to what we see here. So we know that's going to be letter B. Very well. Let's go on to the next problem. Remember, we always want to look for the rate, the y-intercept, and the equation. So on the rate here, let's read the problem. A customer deposits 9,800 into a local bank. If the bank provides 7.5 increase to the account each year, which of the following graphs represents the situation? So we notice that this is going to be increase. We notice that we have a percentage, and we notice that the initial value is 9,800. So let's go ahead and start with the rate. The rate's going to be 1 plus, we need to change the percentage to a decimal. So let's write 7.5 And we're going to move this decimal place 2 places to the left. So this would be 0.075. So this would be 0.075. And that means this would be 1.075. So there we go. That's my rate. Now the y-intercept is 9,800. That's how much money this customer had at the beginning. And now we're going to write the equation, which is 9,800, open parentheses, 1.75, and raised to the x. So looking at this, we notice here that this is about 9,000. So this is good. This here is about 4,000. And so then we know this is not correct. This is about 9,000. It's kind of hard to see. This one is 4,000. So what we need to do is we need to evaluate by putting a 1 right there and figuring out what value we're going to get for that. So let's take a look. Let's pull out the calculator and let's go ahead and enter the new equation, which is going to be 9,800. Then we're going to open the parentheses, going to be 1.075, close parentheses, raised to the first power. And when we do that, we get 10,535. So 10,535. All right, let's take a look. So number 1 right there, we can see that we see that this would be 11,000 and this is 10,000. So this would be half of it. So it'd be 10,500. So that looking good. Let's check this one here. And 1, this is way up into the 17,000. So this is definitely wrong. So with certainty, we know it's letter A. All right, let's take a look on the last example. We need to decide which equation would represent the situation. So let's go ahead and do rate. Let's find the y-intercept and let's find the equation. Okay, very good. A particular type of cell doubles, so we know that's 2, in number every hour. Which function can be used to find the number of cells present at the end of each hour if there was initially 7 of these cells? So we know the y-intercept is 7. We know the rate is 2. Okay, because there's no percentage, we know that this is going to be the rate. Okay, so there'll be equation equals the y-intercept 7, 2 is the rate, and raised to the x. Now, if you notice right there, the multiple choices have n and h instead of y. So basically, instead of y, they're using n, and 7, and then 2, and then h. So basically, this is representing the number of cells, and this is the number of hours. So we know with certainty that it's going to be letter B. So there you go. This concludes the lesson for today. There has 3 examples. We're introducing problems where you have to use the graph. So thank you very much for your time. I hope this video was helpful. Have a great day. Bye-bye.